If you're like most people, one of the main things that you want to do with your server is file services. You want to be able to share with people in the same office, or even just store your backups. Maybe you want a place to dump your music files or your pictures so that they're not on your desktop in the event of an emergency. We can do that a couple of ways. The first way that we're going to explore is with SMB or CIFS through a program called Samba. Samba is predominantly geared towards Windows users, and you can also use it on an OS X machine. Pretty much any operating system that you would find on a modern computer will work with Samba. There's two other systems that we're not really going to explore, but just to be aware that they exist. There's NFS, which is the network file system, and is predominantly for UNIX-like machines, although Windows servers can connect NFS, and so can Windows 7. And then there's finally iSCSI, which is a block-based system. Unlike Samba and NFS, iSCSI doesn't export a file system itself, it exports a raw device. And so on a remote machine, another server or a desktop or whatever, you can mount this remote block device and use it as if it were a local hard drive. This series is going to focus almost exclusively on Samba because it's what 99% of people will use. NFS is actually surprisingly easy, and iSCSI is something that you'll see a lot in medium-sized businesses and definitely larger businesses. It's useful, but it's not something that you're probably going to use on a production machine in a small office. So that probably leads to the question of what is Samba? Samba is a set of utilities that allow you to do, quote, Windows file sharing off of your Linux machine. You can create shares like a Windows server. You can have home directories like a Windows server. And actually, if you really get into it, you can do a group policy as if it were an NT4 machine. You can integrate with Active Directory, but you can't mimic Active Directory. And there's a whole lot of other things that you can do with it. For this video, we're going to get a basic file services with permissions, including groups, and get it so that your server will work. And you'll be good with 10 to 15, 20 people with no problem whatsoever. There are a few caveats that I have to go over with you though. First, if you're used to Windows file services and you've used the ACL panel or the permissions panel for the different shares, Linux permissions don't map the same way. So it's not necessarily a shortcoming, it's just a different way of looking at how you do permissions. They don't map one-to-one with the way that NTFS does. So when you open up a share in Windows and you try to set permissions, sometimes you have to do some workarounds in Samba to make it work the way you expect. That's normally not such an issue on a small install. It can be a bigger issue on a large install if you require complete one-to-one compatibility. With that in mind, you can still get probably all of the functionality that you need, and you can't beat the price. So we're going to go ahead and set up two methods. One with just kind of a shared home directory, everybody dumps their files into it. Every company has one of these. And the second one, we're going to add some security permissions, a couple of controls, do some demonstrations, set up multiple shares, and then you can kind of mimic that setup in your own with your departments or with your family. We'll get right down to business and go ahead and install the Samba package. First, after we log in, we're going to want to check out the package itself. In most Ubuntu versions, it's going to just be called Samba, and that's going to install the server-side utilities. When we check out via apt cache here, we can see that there's a couple basic dependencies, nothing too horrible, and that it's moderately sized. The description here is the most useful part. Implementation of the Samba CIFS protocol for Unix systems, provides interoperability with Windows, OS X, and other Unix boxes, etc. and so forth. apt-get install Samba, good enough. Let it install, and I will speed through the rest of this for you again until we get this error. You can see a 404, which is the standard HTTP file not found. apt-get pulls all of its sources by default from web servers, so the errors that you see are going to be web errors. And you'll see some special syntax I've used here with the double ampersand. The double ampersand implies that it will only run the second command if the first command succeeds. Samba is now installed, and we want to check out etc. samba smb.conf. The Samba configuration file is a little unique. You might not see too many configuration files like it, or at least not the exact same structure, but it doesn't mean that it's difficult. It's actually really straightforward. There are hash marks in front of comments, and everything that isn't a comment is something important. Fire up the config file in your favorite text editor and just take some time to go down through it. Check out all the options. You'll notice that it's pretty heavily commented, By now you're hopefully noticing the trend that most Linux configuration files are, in fact, heavily commented. There's a kind of a method of self-documenting that way. As you scroll down, you can see that comments again are in hash marks, and uncommented things like the global right there specify something to the file. For instance, I'm highlighting the workgroup setting. Workgroups are just like Windows workgroups. They're kind of a way of identifying a group of computers together that in theory have something to do with each other, but in reality it doesn't really matter at all. As I keep scrolling down, you can see Win support, networking support, what interfaces you want it to listen on. Most of the stuff by default is going to work. It may not necessarily be as secure as you want to be, but it will work out of the box. One thing I do want to explicitly set is the security equals user directive. User is actually the default, but sometimes it's better to specify things than let the defaults kick in, so that in the future, if the defaults change, your configuration doesn't go all wonky. This first file share that we're going to set up is really basic. The whole point is to make it so that there are as few hurdles as possible between a group of people who are trying to share files. You just need to get your work done, or you just need to pass stuff around, whatever it may be. The first share, the whole point is that it's going to be open and completely insecure. Now, for this I've gone all the way to the bottom of the samba.conf file, and I'm going to define a share. You do that by putting the share name inside brackets, and as long as it's not a Samba reserved word like server, then it will automatically become a share. You can see the example from above that I'm kind of looking at, the CD-ROM share. Now I've done this so many times that I'm actually doing this one from memory. But there are only three things that you really have to care about: the share name, the read-only directive, and the path. And path points to some place on the server that you actually want to share out as the file share itself. Once you have those two or three things, then you can pretty much get by with whatever it is. I'm adding in some additional stuff so that it works a little better, like guest OK equals no. So that part will require that whoever is sharing files on the server actually has a legitimate login account, but anyone who can log in will be able to share. Once you've made your config changes, for at least most of the changes, you have to go ahead and restart Samba. For certain changes you can get by with a reload, but from this point I'm just going to restart it every time. And when you go to restart using the init script, you get this thing about Samba's now been converted to Upstart, and if you would like to do it correctly, you should use the Upstart script. That's fine, just listen to them. It doesn't matter either way. Pretty much anybody who's been doing Linux for more than a year, this is late 2011, will use init scripts instead of Upstart, and love it. So doesn't really matter. Anyway, I'm making a directory for mount file server, which is the path that we've exported via Samba. It has to exist, and more importantly, it has to be writable by the people who you want to have access to it. Just for laughs, here's creating a file system again at super speed. Now, I really don't need to restart Samba, but I did anyway, just in case. There shouldn't be any problem with the file or the directory not existing beforehand. Just in case there is, I decided to err on the side of caution. For another preparatory step, I need to set the password for the student user, which is kind of my default everything works user on this install, using a separate command called SMB password. And now I have to go through the boring exercise of creating some test directories. So I'll just real quick make a test A and maybe a test B so that we can see what the different effects are on Samba from the Windows client side. The key thing here is to check out the permissions. You'll see that test A is owned by student, test B is owned by root. And I want to create a file server group. I'm going to add student to the file server group. And in fact, any other users that we would want to have access to this first file server would need to be in the group. As you can see here, I wasn't completely thinking ahead when I made the first test groups. But what we can do is show you a really neat trick. On the file server directory, we want to set something called the group ID bit, which is done by using a +S to chmod or change mod. And this does a very special thing. On a directory that is +S, as I'm doing there, any files or directories that are created under it will be owned by the same group that owns the main directory. So once we've done that, what we want to do is go back into Samba and set up one more directive. which is going to force any users that try to log into the public share to also be a member of the file servers group that we just created. So this directive, and the one that really does the magic here, is force group. So by doing force group equals file server, anyone that connects to public share is going to be assigned temporarily to the file server group via Samba. This doesn't actually have anything to do with the groups on the Unix machine itself, only how they're accessed when they go through a Samba file share. And then I am also adding force create mode and force directory mode. These are Unix directory modes that we've gone over earlier. I've also intentionally set them to be incorrect, but we'll come back to that later. This is a fairly common mistake, and I wanted to show how the numbers affect file creation. It's what you would probably expect after a few years of experience, but initially it's going to be somewhat confusing. Switching to a different terminal to log in as a different user here. What I really want to do is create some files that are owned by the student user, since the student user is what's going to be accessing them via the file share in a couple of minutes anyway. So we'll go ahead and create the same test directories again, but this time with something that actually makes sense. You'll see they're owned by student, and file server is the group, and the +S mode is still set on the group security bits. That's what that initial change mod +S did from a few minutes ago. This is also one of the segments where I had the choice of making the audio narration incredibly long or packing the screen with useful text, and I decided to err on the side of text. Time for our first look at a different world. Go to start and then run, and then do //server0 or whatever you named your file server, and you should see your first public share pop up. When you go inside the public share, we see the two test directories that I made earlier. Remember, one is owned by student and one is owned by root. First test is create a new file and make sure that it actually gets created correctly. The second test is to click on test B, go to properties, and under the security tab you can see that it is correctly owned by root and that the group is correctly set to file server. Both of those are awesome because it means that our basic security setup is working. We should expect test A to be owned by file server and student, which is what we see there. Now the expected behavior here is that we should be able to create anything that we want to in test A, both one because it's owned by student and two because it's group owned by file share. Test B, however, should probably fail because the directory is owned by root. And it is. Now why did that happen? Let's look at that screen that we were just at before. See that test A was originally owned by student and group file server. Student could write to it, but file server, the group, doesn't have write access. On the other hand, test B, which was originally owned by student, we then changed to be owned by root. So the only user that could read and write from it at the same time was the root user. File server only had read access. So the reason that test A succeeded was because we're running Samba as student. We're logged into the machine as student. But we don't have root permissions to write to test B. So we need to go ahead and correct that problem next. What is the problem? The problem is that for the purposes of shared Samba stuff here, users don't matter. It's all about group permissions. And we can exemplify that by looking at the text file that I created as part of the example. If you notice that just testing is owned by student and file server, but it has the wrong permissions. Student can read, write, and execute, and file server can read and execute, which doesn't make any sense at all. That's a problem with the way that I set the 555 permissions from before. How do we fix it? The correct way is to go back into the smb.conf file and change the file and directory creation mask so that there's something that actually makes sense. It doesn't make sense to dump files into a Samba server to have them executable like this, but not writable by the group. So all the way to the end again, and we need to change around the create mode and the directory create mode to something that actually kind of makes sense. In this case, we want read write, and probably read write. After all, this is an everybody can write to it. So we're going to restart Samba and head back to the other side and make sure that you actually spell SMBD correctly. I just want to make another text file so that I can verify that the new create mask is something that actually makes sense, gives us files that I can access from another user. So go to new, and at the bottom there, what you couldn't see was text to document. We're going to call it testing again and flip it back to check. And then lucky for you, you're going to get to see a side effect of the NT ACL permissions that I talked about before. Even though we set the creation mode to 666 or read write, read write, read write, the new file has executable permissions. Why is that? It has to do with the way that NT and Samba have to map ACLs. Linux file permissions come from a older, maybe more simpler time when you could get by with just having a file owner, a group, and an everybody else security config. NTFS definitely has a improved, if not more complicated, system for access control. You can have multiple owners, multiple groups, and there's varying levels of control, like say you're only allowed to modify but not delete. There's no real analog for that in Linux, so Samba has to do some background magic to make that work out correctly. One of the things that it does is map full control, which is you can do anything to a file, to the Linux permissions of read, write, execute, which is exactly the same. You can do anything to that file. The majority of the time, this mapping process isn't going to matter to you at all. The only time that it comes into play is on the occasion that you want a file to have multiple owners. Normally, it's not a situation you want to get into. The correct way to handle that is with adding more and more groups. But one day you'll probably want multiple owners on a file and get really frustrated about it. Be aware that Linux does have an ACL system where you can have multiple users on it, but it's a lot more complicated. Definitely a direction that you probably want to go in. And if you ever build a really big high-end Samba server, you're going to have ACLs and you're going to have Active Directory integration and a lot of really cool stuff that's outside of the scope of this video. What's inside the scope of this video, though, is setting up a file server where you can have multiple departments that can share private files amongst members of their own department without having to worry about annoying people like me in engineering getting into payroll data. You can do that sort of thing pretty easily. You already have the tools to do it. We just have to set up a couple groups. We have to configure the file shares for some little bit of tweaking with the different groups. And we're going to introduce a couple new features finally for the intranet site, which is going to be handled by third-party developers that work inside the building. Before we tackle any of that, though, we want to give every employee a little bit of private space, someplace they can stash pictures of their dog and their kids and, maybe their cat. Samba actually has a special configuration directive already set up for this. It's really a special type of share called the homes share. And instead of being a single point on the file system, when you enable the home share, it automatically targets individual users' home directories. So that when they log in, they're going to see a share, in my case, called student or whatever their username is. Go find the home section in the config file, uncomment the home's beginning, and make sure that read-only is set to no. Otherwise, they'll be able to see their files but not do anything with them. The create mask and directory mask in this case are okay, because what you really want here are for people's files to stay private. And if somebody has FTP access to the server and the create mask is set to 770 or something like that, then the user with the FTP account can go traverse everyone else's home directories. And in this specific case, turning on valid users is going to set it so that, once again, you have to be authenticated to the server before you can get to a home directory. Save it out, restart Samba, where once again I show my age. I've been doing this for a really long time and old habits die hard. And then we can flip back to the other side. There's going to be two things going on here. The first is that I want to bring up my Server 01 connection again, and I'm going to see the old file server. That's because Windows is caching the file server list on the server until I forcibly refresh it. So one way to forcibly refresh it is to connect directly to the share, which is what I'm going to do here, by going to //server01/student. While I was lollygagging around in the Samba config, my password had timed out, probably because I had to reboot the virtual machine. But there you can see that I connected to my private directory. There's nothing in there because I haven't created any files yet. But if I make a new folder, what we would expect to see is that in home student, there will be now a new created by Samba directory. Flipping back to the console, we want to check our work. Superficially, it looks like we found success. The created by Samba directory is owned by student, the group student, and the permissions are correct also. Having verified the basic functionality of Samba now, we can switch back into the config file and modify and create the shares that we're interested in using for a more permanent server configuration. And for the dear listener's sake, I will remain mostly silent for this part. The only thing that I'm doing here is creating some new shares so that we can experiment with having a little bit tighter security and see what it looks like to have more shares in the config file. The main premise here is that mostly the accounting department would have information on payroll that you wouldn't want anyone else to have. That's pretty much a given in any business. And then we're going to have other shares based on employee kind of zones like engineering or accounting or even the internet development team. I decided to go ahead and clean up the directory structure a little bit so that not everything is just dumped immediately into file server. This also helps us with permissions. And I set up a little bit of sneaky security on you here. Please take note of the plus in front of accounting. In the previous example with no plus, what happened was every user was forced into the accounting group by Samba, which is a process that runs as root. Now what's happening is that you have to actually exist in the accounting group already in order to have your group forced. This is an extra security mechanism so that if someone connects to the accounting share, but they're not in the accounting group, they don't get any type of elevated permissions. You'll also note that instead of having everyone with access to the files, I've set the create modes to 660 and 770. The final 0, which is the everyone else bit on the files, by having it set to 0, even if they get access to the machine in some other method via FTP or SSH or whatever they want, as long as they're not root, they're not going to be able to read the files that were created by Samba. Just another layer of, hey, don't let them get to the payroll data, or if you're in IT, hey, don't let them get to the Flash videos. When you go through and start adding all the groups to match this up, please do keep in mind that all the Unix accounts are case sensitive. Look at how clean that is. We've got all of the directories that we need. They're all G plus S so that the group membership cascades. And hopefully once we switch back over, we're going to have an account that can access IT but doesn't have any access whatsoever to accounting. Let's try out the good access first. Hot diggity. Since student is actually an IT nerd, it's probably okay that he can see the files in accounting, but what we don't want him to be able to do is manipulate them. So we've succeeded in that because he's not a member of the accounting group. So one last scenario. You're a company that's going through a series of layoffs for everyone except your Linux engineer, and you have outsourced your intranet development to a third party. And you don't want the IT staff that you're thinking about laying off to be able to get in and deface your company website. So we're going to create an intranet dev group and give them Samba permissions to a specialized intranet development location, one of which is going to actively reject people who aren't inside of the group that can get to it. The only thing we're going to change here is the valid user stanza, which takes either a list of users or, if you want to specify a group, prepend it with an @ symbol. The only other difference is that I'm going to once again change the creation modes, because we have to remember that Apache is reading from var www and not just users in this case. So we have to make sure that the www data user, which is what Apache runs as, has read access. So mode of 4 for read only and a mode of 5 for read execute should be sufficient. Instead of restarting Samba this time, I'm going to reload it. Reload has a slightly different function. Instead of killing all the Samba processes and restarting them, Reload just kindly asks Samba to reread its configuration file instead. The problem here is that it doesn't force disconnect users that are already connected. So if you go to your client and you expect to see the new share immediately show up, you're not going to. You can get around that by hitting F5. What you don't want to do is restart Samba when people are using it, because document saves are going to just kind of go missing in flight, potentially. In a lot of cases, though, it's okay. The cache will eventually time out, and you'll be able to see the share that you were interested in after a couple of minutes. Now, as I was recording this, the machine that I was recording it on was configured as a pretty generic Linux server because I wanted it to be the experience that you would have. About this time, though, I got really tired of dealing with non-syntax highlighted text. And so I decided to install a slightly different version of Vi called Vim that doesn't ship as the default, but it has syntax highlighting and some colorization. It makes editing the Samba config file, and really any config file, a whole lot easier. So as a side trip, I'm going to go ahead and install Vim. I recorded this specifically because in a couple of screens you're going to see a colorized version of the config file and wonder what I didn't tell you. Pick your favorite refresh type here. I'm going to right click because it's more visually appealing in a visual medium, but an F5 would have worked just as well. The important part is that when we go to the intranet share, it should reject us outright instead of letting us go into it and see files that we don't have access to anyway. In this case, rejection means simply asking us for the password over and over. Now I want to add the student user back into the intranet dev group so that I can access the file share, and we'll use it for some further examples. One of the kind of use cases that we want to test for is when Samba is restarted when a user has a file open. So I'm going to create a new text file and save it, but not close the file, and then restart Samba on the back end and see what kind of user experience you get out of it. Time to introduce another command called SMB Status. SMB Status shows you the list of open files and shares, what servers they come from, and who has them open. Hopefully there's some useful info here. So we see that there are two services open in the middle of the screen, both the student service, which is a share, and the internet share, both opened by Saturn, and what the process ID is that's running it. You can also see that the user student is connected from 11.10, which is Saturn, and that there are currently no files open for locking, but that var www internet is opened. To test our behavior here, what we want to do is find the process that matches the process ID that Samba reported for the student user, 7309, which is listed as SMBD-F. And we're going to kill that process using a -9. -9 means an immediate kill. As soon as you do an SMB status, we should see roughly the same information, but a new process ID. The new process ID means that Windows automatically reopened the connection since the window or the share or whatever you want to call it was still open. Now, the behavior that we would expect here is to be able to save this file immediately, even though we restarted the file server out from underneath of Notepad. Assuming I can save the file correctly, it means that restarting Samba for the generic case of a text document isn't going to make you lose changes in the middle of editing it. It may not be the same for more complicated applications, but since you can save here in kind of a general purpose, it means that it works okay. For example, you probably would not want to try a hot restart on database files. Time to wrap this one up too. To recap, we've created a file server using Samba. You can control access to files using groups and share permissions. There's a whole lot of extra configuration stuff that I didn't even gloss over that you can go back and reset, figure out how it works, and use it. We can create basically simplistic security, or we can create complicated security depending on the needs of what you want an individual file share to have. But the thing that we're missing now is you have important data and you don't want to lose it in the event of a hard drive failure. So we need to figure out how to back it all up.